So point B is on the terminal side of theta. Again, we finished that the other day. You can just throw that right there. Thanks, Chris. We started this one, I think, but I think I was rushing. So we'll just start over a little bit slower. It's exactly like the ones that we did in class, but we have to draw the picture this time. I just told you where the point is. Now we actually have to draw the picture. So point P is on the terminal side. Find the values of the 6 functions of theta. P is at 2, -2. Since we walked through this, I'll kind of do most of the talking. And I know that's not best teacher practice, but that's what we're going to do. 2, -4, 2, -2 would be over here somewhere in quadrant 4. So I'm going to draw my terminal side, which is like the hypotenuse of my triangle. I'm going to drop a perpendicular to make my little bow tie reference angle. And since my point is 2, -2, I'm going to label my horizontal side the X, my 2, and my up and down vertical side, my -2, the Y. Everyone okay with that so far? Okay, now we have to find the hypotenuse, which we've done with Pythagorean theorem. So I'm going to do 2 squared plus -2 squared equals c squared. 2 squared plus 2 squared is 4. -2 squared is 4 equals c squared, and that equals 8. So if I have radical 8 equals c, the only thing I do want to do here, I'm not going to make you rationalize, but I do want to simplify the radical. So this will become 2√2. Do we remember how to do that, or do I need to review real quick? Did we do that yesterday? Or we're good? Okay. 2√2. This is one of those things, if you're like, I'm lost on that, come see me outside of class so I can help you with that. Remember, the hypotenuse is always positive, so I'm going to go label that 2√2. And then now the last thing I need to do before I make it in all my trig functions is I'm just going to label opposite, adjacent, hypotenuse, and then I'm just going to plug and chug. So opposite is -2, adjacent is +2, and hypotenuse is 2√2. We remember SOHCAHTOA, or at least if we don't remember it, we can write it at the top of our page on anything and recall it very quickly. So I can do sine, cosine, tangent super easily. Sine is going to be -2 over 2√2. Again, you do not have to rationalize, but I do want it simple. So there are too many 2's, so cross those out to get -1 over √2. Cosine is going to be 2 over 2√2. Again, simplify to be 1 over √2. And then tangent will be -2 over 2, which is -1. The good thing now is I'm going to go just do cosecant, secant, and cotangent. I'm just flipping everything. So cosecant and sine go together. So reverse that. You can just make it -√2. Secant is going to be +√2. Again, I'm just flipping that 1 over √2 to be √2 over 1. And anything over 1 is itself. And then -2 over 2 is like 2 over -2, which is still -1. Very similar to the ones that we were ending class with yesterday, but we had to actually draw our picture here. Any questions on this one? All right, we're going to do the next one. So if you're ahead of me, go ahead and draw your picture, figure out what quadrant it's in. I'll come to catch up in a second. Once you figure out a quadrant, try and find the hypotenuse. All right, here it comes if anyone's waiting for me. -1, 4 is in quadrant 2. And the horizontal distance is -1, the vertical distance is 4. And then when you do Pythagorean theorem, you get √17 as your hypotenuse. If you don't believe me, I'll go do it up here. -1 squared plus 4 squared plus or equals c squared. So when I square everything, I get 1 plus 16, which is 17. And I know sometimes we're used to radicals being ugly and us not liking them, but I actually enjoy having a radical that I don't have to simplify, I don't have to do anything for. It's going to be pretty normal for us to get radicals. Once I do that, label opposite, adjacent, and hypotenuse. And then we do our sign, which is opposite over hypotenuse. Again, it's okay that you don't rationalize here. Cosine is going to be -1 over root 17. Tangent is going to be 4 over -1, and I think it's cleaner to write just -4. And then once I get those three, I'm just going to go do the reciprocals for cosecant, for secant, and for cotangent. So root 17 over 4, root 17 over -1, which is negative root 17, and then -1 over 4. All right, any questions? We've done 4 types of problems that are similar to that. Any questions on those so far? Any thoughts? All right. Janae, I got your quiz. Cam and Anaya, make sure you send me your quizzes. Oh, I
thought I sent it.
I got it. Yeah, I got it. Sorry, Anaya. Yeah, make sure you send me your quiz. We're gonna go over to do that after we do one more thing, which is actually gonna work well in our lesson. We're gonna skip number 3 for today, but we are gonna do number 2 really quickly. This is a skill that's not hard, but every year I have like a handful of students that like can't ever seem to do this on a quiz. To me, that seems like a lack of effort and we just forget about it. So I really want to stress it. I even told the other class, right, like this will be on a test. Like you need to know how to do this because it's really not that hard. And I hate when we miss easy points. Like I get when it's something that's like takes a lot of steps or is more difficult, but this is such easy points. That being said, we got to lead up to it, right? So I said, find the positive and negative coterminal angle for whatever. I'm sure half of you are like, Miss White, how is this that easy? I don't even know what coterminal means. Well, I'm here to help. Where would 100 degrees be on my like axis? What quadrant would that be in? 2. Somewhere here in quadrant 2, right? It does not have to be perfect or exact, but it's somewhere here in quadrant 2. And I draw a little arrow from the positive x-axis up to the angle, and I write 100 degrees. The terminal side is the side of the angle that is not the positive x-axis. So when I told you about standard angles, I said we always have one of our sides is the positive x-axis, and then the other one is just like somewhere in space. It's like a clock hand that goes like around and around wherever we want. We don't even draw this angle over here anymore. Like we barely draw that positive x-axis anymore because we're just so used to it now. Everyone right with that? When I'm saying I want a coterminal angle, we're going to find a different way to get that angle by going around the circle in a different manner. So the first way is to go around backwards. Anyone have any idea on how I would label that angle? How would I go if instead of going up to positive 100, what if I went down and around the other way? 260. I'm going to do one more thing. I don't want it to just be 260. I want it to be negative 260. Whenever it's negative, whenever I go down and around to find an angle instead of up and over, that is a negative angle. So to get that, how did you get 260 first? We minus 360, right? We did some kind of minusing. I want us to always think of it as the angle given to me minus 360. So if you do 100 minus 360, that equals negative 260. Now, another way to get the angle is if I go all the way around the circle and then around to 100 again. How would I find that angle? $100, right? Whatever angle was given to me. So 100 plus 360 is if I go all the way around and then back to where I was. So 100 plus 360 is going to be 460. All three of these angles are referencing the same angle, the same coterminal side. 100, negative 260, and 460 are all the same. 100, negative 260, 460 are all the same angles. And so all we did was we minus 360 and we added 360. Okay, let's actually skip the radian for right now. Let's go do the other degree since we're already in the degree mindset. Negative 150 is no different. I'm going to start the same way. However, instead of going up and over like we normally do, instead of going like this way, we have to go down and under. What quadrant will negative 150 be in? 3. We're not going all the way to negative 180. And now we have to do plus 360 and we have to minus 360. When we do plus 360, that's us going the positive direction. So negative 150 plus 360 is going to be 210, I think. And then now I'm going to do minus 360. So I'm going to have a big negative, negative 150 minus 360. Because I'm going all the way around to negative 360 and then around a little bit more to get to negative 150 again. So negative 150 plus negative 360 or minus 360 is, I believe, negative 510. So what we've done these last couple to find the coterminal angle is we've added or subtracted 360. See what I'm saying? Like, it's not a hard skill. You don't even have to draw it. I'm just a very visual learner, so I want to draw it so I can see what I'm doing. But you can just do the number minus 360, the number plus 360. I'm going to do the exact same thing in radians, but what is this? What's the same thing as 360 degrees in radians? What's the radian measure of 360 degrees? 2 pi. Wow, you guys knew it better than the other class. Good job. I always drag the other class in this class, and I'm always on recording, so I got to stop that. We'll see if they watch this and bring it up to my attention. 2 pi. So you guys knew 360 and 2 pi go together. Perfect. If you didn't know that, let's start knowing that. So instead of doing plus or minus 360, I'm now doing plus or minus 2 pi. So I'm going to do 2 pi over 7 plus 2 pi, and I'm doing 2 pi over 7 minus 2 pi. Now, I don't know if you can see what's on the board behind me, especially those online, but we had like some fraction issues last class. Are you guys okay with me writing 2 pi instead of 2 pi, writing it as 14 pi over 7? When I have like a whole number, like 2 pi, we wanted to have a like denominator as 2 pi over 7. So in order for it to have a 7 as a denominator, I need to figure out what my new numerator is going to be. So what I did is I went back to like elementary school math and took like a whole piece and cut it into 7 pieces and another whole piece and cut it into 7 pieces. So I have 14 pieces broken up into 7. Also think about it this way, 14 divided by 7 is 2. So 2 pi is the same thing as 14 pi over 7. Is everyone cool with that? Okay, quick fraction reminder if you were not. Just like denominators. We're used to getting like denominators. We've done it before, but sometimes we've stuffed so many things in your brain that we forget. Just a little reminder about fractions. 2 pi over 7 plus 14 pi over 7 is 16 pi over 7. And then 2 pi over 7 minus 14 pi over 7 is going to be negative 12 pi over 7. And we actually lucked out because 16 over 7 and 12 over 7, there's no way to simplify that. So that's as simple as that one gets. And so I even wrote myself a little key right here. I wrote plus or minus 2 pi, plus or minus 360. So if you want to remember, anytime I say coterminal, find the coterminal angles, you're adding or subtracting 360, or we're adding or subtracting 2 pi. All right, we're actually going to skip letter number 3. I just don't feel like doing that today. If I decide I feel like doing it, I'll teach it to you on Monday, but I don't want to do that today. What I do want to do is go over the unit circle quiz now. So, Cam, have I gotten it yet? My Wi-Fi has been really acting weird these days. Cam, you going to send me your quiz? Oh, he chatted me. Okay, Cam, I'll look at the chat. Everybody else, you can write this on a second sheet of paper. Kim, something's happening. Can you try again? I don't doubt that you sent it to me, and I could be a me problem, but can you try again? We are still going to go over it. So whenever you get that figured out, Cam, let me know. I'll have to figure this out for online, especially because we're all going to do this online on Monday. And so I'll come up with a better method, but that was as good as I could think of last minute this morning. So thank you guys for dealing with that. Please do not write this on your unit circle. If you find space in your notes, you can write it, but I'm just going to go over every single problem that was just on your quiz because we're going to keep doing this. And so I want to make sure that like we know what's happening on these quizzes. I tried to just sprinkle in a little bit of secant and cosecant today. You guys have gotten much better at cosine and sine from even yesterday. Would you guys agree? After we went over that, we seemed to get it. So I'm not trying to like get you every time we do this. Like I want you to do well at this. So that's why I want to go over it and make sure that we understand any mistakes that we made. So if you want to, feel free to write this on a separate sheet of paper and maybe have your unit circle up with us. And if you don't like your unit circle, there's a super easy way to just Google it. Did I get rid of my Google? Oh, here it is. Just Google unit circle and print that off. You can use that. Now I've given you extra information that I would probably want in addition to that, but you're welcome to just Google print a unit circle to use while I'm still letting you use it. So cosine of 3 pi over 2. Does anyone remember what that is? Or can someone tell me what that is? Cosine of 3 pi over 2 is 0. Very good. Remember that we're looking at 270 and cosine is your x. So we went to the x value of our 270. What about sine of 7 pi over 6? What sine is that, x or y? Y. And then 7 pi over 6, -1/2, right? 7 pi over 6 is the same thing as 210 degrees. Cosine of 240, cosine is our x. We all good back there? No. What happened? No, I thought cosine was y. Oh no, Quiva. That's not funny. I'm so sorry for laughing. Now that I know that, I'll go and look at your quiz that way. But what I would probably notice that pretty quickly, Quiva. So I'll grade it according to that. But like now you know. Or what. And that's why we're doing this every day. I don't want this to be a get you when we get to the test. Like we're practicing it because I want us to get good and better at it. Okay, cosine of 240. That's my x value. -1/2. What about sine of 30? Sine is y. That's 1/2, right? Cosine of 90 is your x, which is 0. So my first 5 answers were all like 1/2 or 0. That happens sometimes. Any questions on that? Thought that was pretty easy at the beginning, right? Everyone feel okay about 1 through 5? All right, now we're going to cosecant. I did throw a bonus cosine of 2 pi. Let's do that one really quick because that's easy. Cosine of 2 pi is the same thing as 0. It's my 1. 2 pi is my 360. Yep, that's 1. Okay, this is where I think we got confused. What was hopeful to me is a lot of us seem to get the first step right. Cosecant is what in terms of x and y? 1 over y. So I'm going to go to 45, and I'm going to do 1 over the y at 45, which is root 2 over 2. A lot of us got here, and then we're like, what next, right? Anybody feel that? Some of us even went one more step further and like, okay, now I multiply by the reciprocal, and so I'm going to get 2 over root 2. I told you for today that was cool. I'll accept that for full credit. What I do want to do in the future, though, is rationalize that. I care about rationalizing with unit circles. I don't care with other things. I'm going to multiply by root 2 on top and bottom to get 2 root 2 over 2. And I cross them out, and I just get root 2. Any questions over there? Oh, okay. Go well. Yeah, Bella. So in order to rationalize a denominator, you multiply the radical on both top and bottom. Oh, I took this as an okay answer. I will take that today as an okay answer. Yeah. Gabby? For today, no. So this is what I mean by like, now we know, so now we do better. Does that make sense? But what I really wanted to see is that you knew this much and that you knew that this was your y. Now we're going to make it the most correct, okay? Does that make us feel a little bit better? Okay, let's do the next one. Secant is what in terms of x and y? 1 over x. And then what's my x value at 5 pi over 4? Negative root 2 over 2. This is the exact same simplifying as what we just did. So 1 times 2 over negative root 2. This is, I feel like maybe it's the other class, but I keep talking about like patterns. We find patterns. You only have to do secant and cosecant of like 45 so many times before you're like, I know it's going to be root 2. Another thing you could have done, and this is what Jared did, is he went to the back sheet of his paper and he knew that cosecant of 45 was written on the back of our paper. What I was like, couldn't tell you, Jared, was that if you knew that they were all like 45 degrees, you could have used the 45 on all of these ones that were like in reference to 45. So this one, and this one all have a reference angle of 45. So you could have used your 45 cosecant and secant on the back side. You see what I'm saying? Did you do that? Okay, good. And if not, you can always set it up this way. I had kids in the other class who said, okay, well, I knew that secant was the reciprocal of cosine. So if cosine is root 2 over 2 or negative root 2 over 2, then I just went immediately to this step. That's also okay. There's a lot of different ways to get the right answer, but at the end of the day, I want this to finally be negative root 2. Secant of 2 pi over 3. Secant, we just said, is 1 over x, and then the x at 2 pi over 3 is negative 1/2. So if you want to do your reciprocal for that, that's negative 2 over 1, which is just negative 2. And then last, cosecant of 315 is 1 over y of one of my 45-degree angles, but it's negative. So again, I'll show this one out one more time. Negative 2 over root 2. And then rationalizing means multiply by the radical on top and bottom. And then one final step is just simplify it as much as possible. Those 2's are too much. Okay. All right. Questions, thoughts, comments? If you did not understand, do you feel like you could have done this better a second time? If I gave this back to you right now, do you think that you could figure it out better? Okay, that's all I can ask. On Monday, when I give this, we'll also have tangent and cotangent. Do you remember what tangent is in terms of x and y? Y over x is tangent, and then cotangent is x over y. And we'll actually do a couple examples of those today. So if those are still confusing, we'll do more of that later. All right, any questions? Any thoughts? All right. My only goal is for us to improve on these daily quizzes. So I just want to see an increase, or once we get to the top, that you stay up there at the top. All right, let us go back to our notes. And actually, no, I lied. We're skipping number 3, but before we do number 4, I want to go back to your unit circle. And I want to add one more reference on your unit circle. Sorry, I know I'm jumping around a lot today. It's kind of where my brain is at. Anybody else's brain crazy? I was like really getting this online teaching, and then the last couple weeks, I am just like losing my mind. I just like don't know what day it is. I don't know what classes we see. I cannot keep it straight in my head. So if anyone else is struggling, I am very much struggling. So at least we're both struggling together. And if you're not, then I'll just be struggling by myself, and that'll be okay. Okay, I want to add one more thing to this unit circle, which is going to be helpful. Have you heard other pre-cal students say something like all students take calculus? Has anyone ever said that around you? All students take calculus? Okay, usually by the time we've done it, like some of the other classes have done it before us. So sometimes you guys hear it before you get to my class and do it. We're going to label the quadrants in order for that. So we're going to say A for quadrant 1 for all, S for quadrant 2 for students, T in quadrant 3 for take, and then C in quadrant 4 for calculus. Now, obviously, it doesn't mean all students take calculus, right? That's a little mnemonic, a little cute thing we do so that we can actually remember what it means. What I just told you is which trig functions are positive in each quadrant. In the first quadrant, all of my trig functions are positive. Cosine is positive because my x is positive. Sine is positive because my sine is positive, because y is positive. And then you guys just told me that tangent is y over x. So a positive divided by a positive is positive. So you can look anywhere and know that all of the trig functions in quadrant 1 are positive. Okay. Quadrant 2 is S for sine. Sine is positive in quadrant 2. And only sine. Remember that sine and cosecant go together, so also cosecant, but that would not fit with our little mnemonic, so we didn't put that in there. Sine is positive because y is positive. Cosine is negative, so it's not positive. And then if I do tangent y over x, a positive divided by negative, that's negative, so that's not positive. So sine and cosecant are the only ones positive in quadrant 2. Quadrant 3 is T for tangent. Tangent is positive. The reason tangent is positive here is because both sine and cosine are negative. Both x and y are negative, both sine and cosine are negative. But when I do y divided by x, negative divided by negative, that's a positive number. So tangent and its reciprocal cotangent are both positive in that quadrant. And then last is C for cosine is positive. So quadrant 4, cosine is the only trig function that's positive there. Sine is negative because y is negative. Cosine is positive because x is positive. And then tangent is negative, though, because it's a negative divided by a positive, which will stay negative. Okay? So that's kind of half the battle. If you can recognize which quadrant it's going to be in, you can know whether it's going to be sine or cosine. Or sorry, if you know which quadrant it's going to be in, you can know whether it's positive or negative based on the trig function I gave you. So we're going to practice that a little bit now. Okay? So now we added that to our reference sheet. Our reference sheet is so busy. We've got a lot of fun things on here. We're going to move back to our notes and use this skill. So I feel bad I was not fast enough with the other class for that. So if anyone from the other class, look at that first, and then we'll go to these. Number 4 says tell the sign, which means tell if it's positive or negative. And what we're going to do is let's do the degrees first, right? We're all more comfortable with degrees. Let's go to degrees. Okay. Sine of 152. What quadrant is 152 going to be in? 2. Is sine positive or negative in quadrant 2? Positive. That's it. The end. If you need a little bit more assistance than that, let me draw you a picture. I drew my quadrants. I'm going to write all students take calculus. We are in quadrant 2. That's where sine is positive. The end. You don't even need to show any work. You can literally write positive and call it a day. What about E? Tan of negative 200. What quadrant is negative 200 going to be in? Remember, we have to go down and around. Then we gotta go down and around to 200. 2. Remember when negative angles go down, so I have to go past negative 90, past negative 180, and I go a little bit into quadrant 2. Everyone okay with that? Is tangent positive or negative in quadrant 2? Negative. And last one says secant of 500. Whew, that's going to be a lot. 500 means that I go at least around to 360. I at least go 360, and then I'm going to have to go more. How much more from 360 am I going to have to go? 140. And which quadrant is that going to be in? 2. So I'm in quadrant 2. I would probably, I'm at least going to write Q2 over there just so I know which quadrant I'm in. And then secant. Secant goes with which trig function? Sine, cosine, or tangent? Cosine. And is cosine and thus secant positive or negative in this quadrant? Negative. Are we okay with that? Okay, we're going to do the exact same thing now with our radians. The radians doesn't make any difference, just sometimes we're a little less comfortable. But again, I'm just going to identify the quadrant and then decide whether it's positive or negative based on all students take calculus. So cosine of 8 pi over 9. What quadrant should that be in? It's not 4. Remember that my markers are pi over 2, pi, 3 pi over 2, and 2 pi. So 8 pi over 9 is not quite 1 whole pi. It's somewhere in quadrant 2. Yes. And is it positive or negative? Negative. Everyone good? So 8 pi over 9, is that 1 whole pi yet? Is 8 over 9 1? It's less than 1, right? Well, 1 pi is at 180. So it's a little bit less than 180. We want to keep thinking of it as going around 1 whole circle. Remember, 1 whole circle is 2 pi, not 1 pi. So I have to go all the way around. To go all the way around, I have to do 2 pi's. Half of it to 180 is 1 pi. Did that help a little bit? Awesome. All right, next one is cosecant of negative pi over 7. So I'm going down and around this way. Is it going to be in quadrant 1, 2, 3, or 4? Good. Jared, why is it going to be in 4? Yeah, it's a small negative angle, right? I'm only going a little bit down into the 4th quadrant. Negative angle means I'm going this way, not up and around. I'm going down and under. And pi over 7 is not quite pi over 2 yet. Cosecant goes with which trig function? Sine. And is sine positive or negative in the 4th quadrant? Negative. I do not think this is a difficult skill, but what's hard is it's not like we're mathematically finding it. Like we are reasoning our way through this. And so if you have, if you want to sit and talk about it a little bit more, I'd love to do that because this is a little bit of reasoning stuff. The last one we're going to do today is cotangent of 25 pi over 8. Ooh, that's wild. Let's talk through that. Is 25 pi over 8 1 whole pi? Is it 2 whole pi? Is it 3 whole pi? Is it 4 whole pi? No. It's just a little bit more than 3, right? How did you know we could at least go up to 3? What do you guys do in your head? 25 divided by 8, right? You're like, okay, we go at least 3 whole things and then whatever left. 25 pi over 8 is just going to be a tiny bit into the 3rd quadrant. Cotangent goes with which trig function? tan, and is it positive or negative? Positive. Awesome. Cam, let me check my emails. I got one, Cam, I got one just now from you. And if you sent the first quiz, I didn't get that yesterday, but I didn't count it for points, so you were fine for the first one. So you attached both. So I know you can't see my screen, but we're good, Cam. That one is positive, yeah. I didn't finish. There we go. All right. The 8 pi over 9 is in the second quadrant. Is that what you're asking about? No. Oh, sorry. That's in the third quadrant because 25 pi over 8, we did 25 divided by 8 kind of in our head, and we knew that we at least did 3 whole pies and then a little bit more. So we would only have done, that's a great question, actually, Al. So it would have been a 3 and then pi over 8 because 25 over 8 would be 24 over 8 and then an extra 1/8. 1/8 is a really small amount, and it's between like 0 and pi over 2 because all of these like quadrants are like half a pi, half a pi, half a pi. I'm listening, Al. So like 25 pi over 8. This pi would have been 8 pi over 8. That would have been pi, right? And then another pi would be 16 pi. We're not there yet. We got to keep going. Now I go over here to 24 pi. And then I'm just going pi over what's left in quadrant. This whole quadrant is on the pi over 2. So it takes a 90 degrees to get through this whole thing. So pi over 8 bigger or smaller than pi over 2? Smaller, but how much smaller? Gabby, you asked about letter B. Letter B was in quadrant 4. Letter B was in quadrant 4 because I only went a little bit in the negative direction. I went pi over 7 in the negative direction. All right, we're going to do letter 5. We got to number 5. We got to letter D in my other class, and that didn't kind of work, so the pre-calc going in like 3 minutes, so we're going to do a couple of these all together. This is just your unit circle. So I want you to pull your unit circle up. We are going to just do these using our unit circle. The first one's actually super easy. Sine of 150. What's sine of 150? 1/2? Perfect. This is just like we've been doing our quizzes on. Let's do a cotangent one and hopefully a tangent one before you have to do it by yourself on Monday, right? So does anyone remember what cotangent is in terms of x's and y's? X over y. And pi over 3, what's your x value at pi over 3, at 5 pi over 3? 1/2. And then what's your y value at 5 pi over 3? Negative root 3 over 2. Good. Remember that 5 pi over 3 is at like your 300 mark, which is in your fourth quadrant. I'm going to do my simplifying just like I was doing earlier today. I'm multiplying by the reciprocal. 1/2 times 2 over negative root 3. The 2's cancel out. So I'm left with 1 over negative root 3. But I told you on unit circles, I want this rationalized. So we're going to rationalize this times root 3 on top and bottom. So I get negative root 3 over 3. Is everyone okay with that? Okay. Let's try the next one. Cosecant at 3 pi over 4. Cosecant is what in terms of x and y? 1 over y. Root 2 over 2. We've done this enough times today. Does anyone remember what it is just because we've done it like 4 times? Anyone remember how this simplifies down? It's just root 2. If you didn't know, you can still do your multiplying. Multiply by 2 over radical 2. I get 2 over root 2. Multiply by root 2's. 2 root 2 over 2 root 2. Wow, that was a lot to say. Or as we know, we'll just be able to simplify it. All right, we're just one problem behind the other class. So I will stop the recording just so people online don't have to listen to